This is the last lecture in our module 1. I wanted to do last week, but somehow some goof up didn't happen, which is fine. That means on Wednesday, I'll probably take 2 classes continuously, cover it up. So far, we have been discussing MapReduce, and in our MapReduce programming, we basically define one mapper process and one reducer process, and they get executed. First mapper, then the reducer. I'm not saying how many mappers, but as far as mapper code is concerned, it is the same code that runs. And that's what we have been doing so far. Now we'll see that for good amount of jobs, single mapper and single reducer is not good enough. And we would need a sequence of mapper, reducer, mapper and reducer, and so on and so forth. And when we run the sequence of mapper and reducer one after the other, that is a concept called MapReduce chaining. And that's what we'll study now. We'll also briefly look at, in case you face problem, how do you debug? Primarily because debugging, the parallel execution is very, very tough. Hadoop gives us scaling, and when we debug large amount of data, it really becomes challenging. And I really had experience when I was working in a field. I was reported that whenever you download more than 2.1 GB of data on Android phone, we had some Android working on that before coming to KSIT, it aborts. And that means I had to do a word SAR capture, which amounted to 10 GB of data. It's a huge amount of data and almost took 2-3 days to figure out what is going on. So when you have large amount of data with parallel with Hadoop, debugging would be difficult. So what is that we can do to simplify, understand that our programs are correctly, we'll be able to debug the programs. When I look at the book, it probably gives you very cursory view, not in detail. So looked around web and found some good resources sharing the same. So if you want to really look at chaining, above is a good resource which you can look at, and it nicely explains you what a MapReduce chaining really means at a conceptual level. This is mostly in Java. Those who would like to use Python, Python has a module called MRJob. MR is basically MapReduce job that enables you chaining. I mean, you can run MRJob even without chaining, or you can run with chaining. That means there's another part of module called step, MR step. You define multiple steps of MR jobs, put them in sequence, and that achieves your chaining. So you can look at those, understand those, and those who would like to use Python for your general programming, Hadoop, MRJob is a good place to start with for a code. So let us look at why and where we need chaining. As we said, in most of the places, a good number of real-life program, a single instance of map followed by reduce is not sufficient. And to do that, it becomes too insufficient. We want to run a mapper, then reduce will give a result. Then output of reduce, we want to feed it to a mapper, then another reducer, and then so on and so forth. In fact, it could even be more complicated than a single chain, and the MRJob, other places you can define that as well. It also happens that we are dealing with multiple data set. So one MapReduce we deal with one data set, another MapReduce instance we deal with another data set, and then you would like to combine the output of these two MapReduce with third MapReduce and so on, so forth, and that can happen. So primarily when we use chaining, You basically are running a number of MapReduce programs in certain order, and that when you run certain order, that basically constitutes or makes it a bigger job to achieve. And that primarily is chaining. As we said, chaining need not be just sequential. It could follow a what is called directed acyclic graph, dependency of jobs. Would anyone like to explain what is a directed acyclic graph, or called DAG? Amog? What is a directed acyclic graph? Indrasena?
It, it has a like every like we represent it using arrow marks. Like every arrow has a weight representing.
Weight need not be there. Weight is by default is not there. You can assume one or whatever uniform weight. So weight is not a criteria, but go ahead, please. So what does arrow mark mean?
Means it's a path. Like there is a path which exists from that particular edge to other edge.
No, not as to other. The node from node to node, node A to node B.
Yes, node to node, and also it has no cycles.
Yeah. Yeah. Somebody else saying something? Go ahead.
Yes, Rai said there are no cycles in acyclic graph.
Yeah. So how do you define cycles? So if you look at a undirected graph, and I say there is a cycle, and on the cycle path between, let's say there are two nodes on a cycle path, and the nodes are A and B. And if the path involves the two nodes A and B, can I say that from A to B, I can reach by at least two paths? Is that true? If there is a cycle involving node A and node B on an undirected graph, can I then say that from node A, I can reach node B in at least two different paths? Meghna?
No. Yeah.
No, yes.
No.
What is the answer? You said no or you said yes? Who said yes?
Yes, only, sir.
Yes. Can you explain me why?
From A to B, and again it can come back to A, B, and A.
No, but I'm saying between A to B only. I'm not coming to A. All I'm saying is, if there is a cycle and on the cycle lies two nodes A and B, then I'm claiming that between A and B, from A, I can reach B at least via two distinct paths.
No.
No?
Yes. No.
What does a cycle mean?
When you start from a node, you reach, you come back to that
Let's
same
say
node.
I start from a node A, then I go to node X1, X2, X3, and reach node B. And because there is a cycle, that means there'll be another path, Y1, Y2, Y3, that will go back to node A. Is that right?
Yes, sir.
So that means there is a path A to B, X1, X2, Xk. And since it's an undirected graph, there is another path called Yn, Yn minus 1, and to Y1 to B. So when we say cycle in an undirected graph, that basically means between two nodes which come on the path of a cycle. That means between these two nodes, there are at least two distinct paths. Is that okay? Am I clear, or there's a confusion there?
Yes, sir. Yes, sir.
So let's say from node A, let me repeat, node A to B, there is a path x1, x2, xk, and then B, and then B to A, path y1, y2, y3, ym to A. That's how you make a cycle. So cycle would be A, x1, x2, x3, xk, B, y1, y2, y3, yl, A, and that becomes a cycle. So that means there is a path A to B, there is a path B to A, and because undirected graph, path B to A is same as path A to B. So you can reach B by at least two distinct paths. Any confusion about this?
No, sir.
No. Now let's look at directed acyclic graph. When I say that from node A to node B, I can reach via two distinct paths. Does that mean there is a cycle or there is no cycle? I'm talking directed graph and saying from A to B, I can reach via two distinct paths. Does that imply there would be cycle involving A and B?
No.
No. Because when we say directed graph, we always define one way. When we have a directed as A to B, it only implies we can reach B from A. It does not imply that we can reach A from B. And that's the meaning of direction of edge A to B. So when we're looking at our chaining, it need not be a sequence. I could have a job A, I could have a job B, and both could determine that only when A and B are complete, then only job C could be done. So there will be directed as from A to C, there will be directed as from B to C, and A to B there may not be any dependency. And thus we could have the dependency need not be a simple sequence chain, it could even follow a directed graph. In this chaining, you can't have a cycle. Why? Because if B depends upon A cannot depend upon B. Look at our data flow. Data flow is in one direction. A cannot depend upon some node which depends upon by itself. So the chaining normally means sequence, but it does involve, you could define multiple dependencies, and dependency could even for a directed acyclic graph. Just to cover briefly why Python MRJob module. This is not part of your book, but those, I think most of you like to follow Python for a normal developer life ahead. So quickly, just to give you advantage of those who like to use, why to use Python MRJob. The main advantage is you can run your mapper and reducer without actually running a Hadoop setup. That means you can define a mapper, you can define the reducer, run them locally without any Hadoop installation. And it pretty much guarantees you that if you can run them locally and it works fine, it will work in a Hadoop setup as well. You can easily debug, fix the issues, work things up, and then make sure things are. Secondly, once a job has been tested and running using MRJob, then same could be run in a Hadoop cluster. It could be run in the cloud. In Amazon, they call it EMR, Elastic MapReduce, or that means once you run, you are transparent to what my working environment is. It will work everywhere. And that's the beauty of MRJob. Once you are using MRJob, all the required related dependent library are taken care of. You don't need to do separate classes, other things, defining other stuff. When you deal with a lot of Python programs and Python program has to exchange data between each other, you need to possibly do serialize and deserialize. So the data could be interpreted. That serialization and deserialization is automatically taken care of by the MRJob. You don't have to worry about it. So when you define dependency in chaining, that serialization is taken care of by Python, and that frees you from there. Further, it basically other advantages, or you can call it disadvantages, for the internal operations, you basically work with abstract APIs. So you really don't know what is happening. So though if you want to exploit the internal Hadoop structure, you're only dealing with abstracted API. So if you want to do very, very high level fine tuning, that may not be feasible. For that, you may have to use direct Java classes. But for 90% of your jobs, this MRJob is good enough. You don't have to really worry about it. It's something like when you want to do socket programming in Python, you simply do open a socket, connect, server, you start. So all the notion of connecting, binding, doing things up is kind of automatically taken care of. Same way you work with abstract API and be done with it, and it takes care of other part of it. So it doesn't allow you manual fine tuning, but 90% jobs, you do not require that, and hence this should be good enough. Let's come to our chaining requirement. We'll consider a simple example and maybe hypothetical example, though it may, but tell you how does my chaining work. As we said, chaining means at least two instances of MapReduce, one instance of MapReduce, followed by another instance of MapReduce, and that is how the chaining would work. So let's consider a case. Let's look at the marks of VTU students. And so you have a USN and the total marks. And what we would like to do is, our query is to find out what are the top 5 marks which are obtained by most students. Here, I'm not talking about the maximum marks who's the topper, no. Which is that mark which is obtained most? For example, 81 could be the mark that is obtained by maximum students. Next could be 73, third could be 67, fourth could be 84, whatever. So we're interested in those marks values which are obtained by max students. So given that I given you the list of inputs which contains USN numbers and their respective marks, and I would ask you to do that, find the top 5 marks that obtained by most students. How would you approach the problem? Akshita? Lakshmi?
Yes, sir.
How would you approach the problem? Did you understand the question?
Yes, sir, I got it.
So now can you tell me how do you solve it?
So before calculating the top 5, we need to evaluate for the maximum number of students scoring the top digit, by the way.
So how do you do that? That's the question I'm asking you. What do you do? I've given you a file that contains USN number and the marks obtained.
So here we need to consider the logic. Is that so, sir?
Yeah. How would you proceed? That's the question. What the logic you would use? Ganesh? Yeah, go ahead.
So need some time, I'm thinking.
Okay.
So,
Yeah, anybody else can go ahead. That's fine.
sir, I think we can use dictionary key value pairs.
How will that help? What will do? What is the key and what is the value?
Yes, sir. The key will be the marks and value
Okay.
will be occurrence of occurrence, like how many
Fine.
students have got that
marks,
particular.
okay. Count. Perfect. After that, what do you do?
Then yes, you will get the values of all values
the
of
marks. Yeah.
all the keys in the dictionary and print in a descending order.
No, I want only top
Okay.
5 descending order. That is important. So
Uh,
basically, you're doing sort. That precisely the job. So look, we have 2 jobs involved here. First is you basically find frequency of all the marks. Now, whether you use key value dictionary, whether you use plain counter, doesn't really matter. I'm not worried about. So you need to find frequency of each mark, then you sort it out and find the top 5. So that basically means my first MapReduce would be like what you have been doing. For each mark, output marks 1, marks 1, marks 1, marks 1. That's what you've been doing. When you did a word count program, we basically did this. And what did reducer do? It put aggregated marks together. For each mark, it gives a count. And that is what the first map reducer was. So mapper was simply filtering, looking at the marks, outputting marks 1 for 53,1, 84,1, 93,1, and so on and so forth. When all these were outputted by mapper, reducer simply aggregated, say 53, 192 students, 87, 240 students, and so on and so forth. And this one MapReduce was over. Then second MapReduce is, it has to basically do a sorting. Now, if we need to do sorting, we need to do sorting on the count, not on the marks. And once you do a sorting, then job is to get the top 5, and we are basically done. So all that the mapper does is it inverts the key value pair, because what reducer gave you is marks and count. You invert it, count and marks, and then you basically sort it out, and then get top 5. So we have 2 MapReduce jobs that achieve this. And that in a nutshell is basically what you're saying is a chain. Now we'll look at the example of book, what the book has given, what's called Grep. How does Grep work? Basically, when you give a regular expression, it for each line it finds, does that regular expression exist? And if so, it output the line. That is what basically our grep command on Linux does. But what we're interested is in the actual match. If a line contains multiple matches to the pattern, we would like to look at that particular pattern. And that is what we are interested in. And that is what we would like to really basically know. What is that? Grep only gives the whole line as an output. Doesn't matter whether the line contains 1 match, 2 match, or 3 match. So we would like the exact match and not the entire line. And this match could be a regular expression. For example, what does this regular expression do? So let me show you. If we look at a password file, can you see my command screen, or is it too small?
Visible, sir.
Visible. So we look at the password file. It has 7 fields separated by colon. First is the login name, then the password, which is always X because it's kept somewhere, it's encrypted. Then you have the UID, numeric value, group ID, numeric value, description, details, full name, whatever. Then you have the home directory, and then you have the login cell. These are the 7 fields. So my UID happens to be third field. Given that third field, I'm saying, what is this regular expression does? Will this give me all UID with 4 digits in password file? The question I'm asking is, if I were to do this, what will I get? Let me do that again. So see, I am getting UID only, which are more than this. If I were to do this, will I get the same answer or a different answer? Anyone? I change my regular expression to this. Will I get the same answer or a different answer?
A different answer.
What would be different? Will I get less record or more records?
I think more records because
Yeah. Why?
because root has a 0 as the UID.
Yeah. But I'm telling, but the root at 0 ID, I will not get the root record because I'm ensuring that you have at least 4 digits. And root is 0 doesn't have 4 digits. So root record won't come.
Oh, okay.
So will I still get more records? Here, I still, but now let me change it. If I were to do this, you know what this means, regular expression? I'm sure to study it. I given 3 comma. What is the difference between repeating 3 and 3 comma? Chinna?
Yes, sir.
What is the difference between putting 3 comma versus putting only 3? Ganesh GB?
Yes, sir.
Yeah. This is a regular expression. You would have studied it. Can you tell me what this regular expression means? Anyone? You studied the whole Python course. You will study regular expression. All forgotten? See what it means? It means X followed by a colon, followed by any digit, followed by any digit that occurs 3 or more times, comma meaning 3 or more times. Or if I were to say, let's say this says at least 3 times, but maximum 5 times. If I do that, you see you get one more record which contains 4 digits. If I were to do precisely something, let's say 5 digits, you will get only one entry. No, 5 you get anything because this becomes 1 0, one entry plus 5 digits more, that means you get nothing. But if I were to do 4 comma 5, then you get entries because it makes 5 digits. So to explore, look at it, and that's the question I'm basically saying. So we'd like to take a password file. We would like to know how many users are there which have a UID consisting of 3 digits or 4 digits or 5 digits. And I'm using this example for chaining. So basically run two MapReduce job. First will count the number of matches in the input. It will give you frequencies. And then second job basically sorts and match as per the frequency. That's all we're trying to do. Something similar what we did for the marks part of it. Or we could look at any other word, any other file, and work that. So I'll look at the program which has been given by in the book, which is also there. If you look at the programs upload files, grep.java, it is a part of, I think, your program 6. So let me say where this would be. I hope I'll be able to show you there. Let's say go to Teams. Files, class material, programs, Hadoop. I believe in chapter 6, Hadoop Grep. You can say Hadoop 2, and you see a file called grep.java. And that's the program I'm looking at. So you know how to compile the program, Java C that you have done before, written Java course, create a jar file, and then we are saying is run the jar file using Hadoop. And now we need to use the regular expression. Please note the difference here. I'm not using backslash, but if I'm using this regular expression using grep on the command line, I use the backslash. Because if I don't use the backslash, cell itself will interpret it and then will not get the right answers. But in Hadoop, when I'm passing it, it takes the whole expression. What this tells is, it tells run the grep program, look at all the files in input directory called myin, and for this pattern, basically founds and gives a count, and put the output in directory called myout. And that is what this grep program does. And you basically run things up and you'll see the answers. And when you see at the end, you'll get the answers and indicate the success, and that's what would happen. So let's look at the basic code, what this fellow is doing. To look at the output, we can do a cat part of it, and we should be fine. So let's look at what the basic code of grep looks like. This is your mapper class. I'm trying to first define this object. Like in Java code, you define a conference configuration file so that you can get the file system access. Because to get Hadoop file system access, you need to get an instance of configuration class. That is when you get, after that, you do things up. Then I'm defining a pattern. And look at my syntax, what I've done. My first input was input directory. Second command line input was output directory. And so if you look at, let me just show you. First input, input directory. Second input is output directory. And third input is the regular expression. So I'm setting the regular expression pattern. This was extra case, so let me comment it out, not using that part. Then I create a first job. So this is the one job, create job. So to do chaining, you'll create two jobs. First is job 1, then the job 2. In job 1, we'll basically count the occurrences using the pattern. So you define the job name, which is I'm doing searching. Using argument 0, which is input directory, you define the input path, and the mapper class, we're using basically the set mapper class. That means we're using regex mapper, which is the job of mapper to figure out. And then combiner class, which will do the sum, reducer, which is same as the combiner class. And then we set the output path. Now for this first job, we cannot be writing into the output directory specified. We create a temporary directory, put that into the output of the first MapReduce job, and this temporary directory would act as an input to the second MapReduce job. To understand the difference, set the output format, and then we basically run the program, indicate grep job, which is my first job which created, wait for completion. That means till this job is completed, don't do anything. And once this is done, then you have second job coming up, which is basically my sorting job. I using a configuration object, I create this new job. In this job, I say my sort job. Again, my input path, which is the temporary directory which we created in the first job. We set the input format, usual process. Now in the mapper, there is no really job. What we say, we need to invert count and the regex. So output of the reducer was regex, mesh pattern, and the count. And my mapper is basically inverting class, which will invert count come first, and then the mesh pattern. And then my reducer is basically doing the sorting, nothing more than job. I'm doing a sorting job, which will do a sort. That's a sort comparator job. And once I run, I should be fine. And I wait for it completion, and the job would run. And since we don't want our temporary directory to be existing, the job is done. We like to remove this temporary directory, and then basically say remove temporary directory. And once the both job runs, then we basically see that our things will happen and program would run fine. So essentially, mapper of first job takes a one line at a time, matches the regular expression, sorts things up. So it's basically Java code, basic built-in classes available. We're using that, or you can write your own code. Does not really matter. So mapper outputs meshed pattern one, meshed pattern one. Then reducer sums up the count, and then you have a second job. First job is mapper is the inverter, which basically inverts key value to value key. Key is the mesh pattern, value is the count. We're saying count and the value, which will basically the reduction we do on the sorting part, and sorting happens, then we get the output. Since we want all in one go, we want to make sure that only one reducer and not multiple reducers. Because multiple reducers, then there will be two different files, and we need to do sort decreasing order ourselves. And that is what basically primary the job is. So in case you want to run, you can look at running the program. I can say SDFS, DFS. Let's say what I have in my directory. So attendance, let me create one directory file. I'll copy some data into it. Let's say which. So I'll say SDFS, DFS put input. It goes in there. I'll define the output directory. It will be created. So I want to make sure that there is no output directory. And now we need to just run compile. I do have a grep classes. I have a grep classes. I should have grep.jar as well. So we know how to copy, run that. You know all that syntax. And so you need to simply invoke, let me run the program. some running Grep program which we compiled, ran it. You can compile, I'm not compiling it. Input directory is the data output and my regular expression pattern, which I'm saying. So it basically give me all the UIDs starting from 1 followed by 3. So let me just change it. Let's say I would like to do 2, comma. That means all UIDs with 1 and 2. That means all UID which consists of 3 digits and 4 digits and no more. When you run the program, it will basically start running up, create a MapReduce job. So it is the first job that is created. It is the first job which will simply put a count, will put into a temporary directory. And once this MapReduce would be over, then which is second MapReduce starts. So this is the first MapReduce happening. Then we have a second MapReduce that will start, and the next job would be 0042. This is what is started, second MapReduce job, and we are basically saying number of split is 1, and once it is runs, you probably get an output. And we said to look at all the files which are there in input directory. So let us look at. Sorry, I don't know what input we gave. We probably made a mistake. Let it complete. See, byte return is 0. That means there is no output. So if you look at we given a my out, so there is no data. And if you look at my input was so if you look at this is what my input is, there is no X colon anything there, and that's the reason you don't find anything. That means we should be running an input on my password file, and I gave a wrong input, so I should make sure that I should copy the password file. We created only directory into input directory. We put CO message, let me remove that. Since we're working with password file, let me copy the password file. Let me copy the password file there. Now I can run the program, change my input directory to input. Let's create my directory as output. And now I should see the respective output. So this basically what I'm saying is how do you debug the program? You have to look at, debug it, look at very small data set, and when you things work out, then you probably get to know how things are running. So the first MapReduce job, which is running right now, once that completes your second MapReduce job, you have to analyze the output. The moment I say byte return is 0, you know something went wrong. Job was successful, but something went wrong and we didn't get the output. So finally, we should see some output being run, and that is where we can actually see that our programs are being run. So this is the second MapReduce job, and after that, you will see some output being returned into the output directory, and we should get the results. Just wait for another few minutes. So byte return 275. So let's look at the output. So see, this is created. I can get the content. And you can see the frequency being given there. You see all this 1, 2, 4, and this is what you basically get here. All unique numbers. Now, if I were to run my pattern with only 100, let's look at that and then see what is the answer. Because 100 will appear in about called 6 counts, then I should see that many places. Let's look at that search and then see what do I get. I can run the same thing, change my pattern. So I would say 0. I'll do only this 1 to 9 followed by 0, and I don't even care after that what needs to be done. And this could be any number of digits, 0 and followed by, I could say 0 to 9, and I can say any number of digits. It doesn't really matter to me. One or more digits. If I do that, that will basically look at the pattern. I'm looking at this, and then you would see what answer I'll probably get. And I change my output to out 2. Let's say output 2, and you get respective output, and that's how things would run. So primarily, you can change the regular access pattern, search for yourself, look at how things are. If you want to do different count, you can do other way out, search for what we want to do, and that will give you the basic answers. And you run, but if you have the same thing, multiple data copies, it looks at all the files. If I were to copy the same file with a different name, then you would see a different answer would be coming up from there. So either you can give a specific single file, or if you copy the same file again twice, you'll probably see every count would appear twice or respective number of times. This is what would happen. So that is complete, and then I'll try to copy that file with a different name there. Let's say, then I can say HDFS, DFS, LS, and our output 2. Sorry, I gave a wrong name. And then I can do and you see what we have done, basically 3 or more, you get those different numbers. So run yourself with a different number. If I were to copy the same data, DFS, port, now my input directory contains 2 files. So if I run the same program, you would see number coming at 2 times. So you plan it out, look for yourself what is to be done, and respectively get the answers. If I were to run this, let's say again, let me remove the colon here. It doesn't really matter. And then I'm saying I'm interested only in this. 1 for x colon 1 to 9 followed by 10 doesn't really matter. And if I were to change my, let's say output 3, you see a different number there. Let the program run. Meanwhile, we'll go through our remaining part of it. I just said, how do you debug? It could be difficult sometimes because of the parallelism. The best way to debug is run application on single system locally, work with a smaller data set, and once you do that, you probably know that you can debug easily with small data set, you can manually trace, and that would work out. And once your testing works on a local machine with a small data set, Hadoop only gives you high scaling, And because of scaling, you can make sure and you are assured that the program would run correctly. Other way to debug is looking at the logs. Now, if you're running in a cluster, logs could be done at each cluster node, or you could create a centralized log. Log consists of 3 files: standard output, standard error, and syslog. And depending on your choice, either you can have individual logs on each node, or you could have aggregated logs in HDFS using YARN. So if you want to do log aggregation in a cluster, if you're running a single node on a laptop, it doesn't really matter. There is not spending time. But in case you want to do log aggregation running on a cluster, then you basically define a log directory under YARN, the resource manager, and define the property saying, look, we want to remote app log directory. All the logs should be defined in this place, YARN logs. When all they are defined, make sure that debugging log is true. We're saying YARN log aggregation enable. So we are enabling log aggregation, making it true, and defining the directory. So all the logs, you'll find YARN log as central HDFS. So when a single node doesn't really matter, you can try this, run it out yourself, and things would run fine. And then you can look at the logs, list job, status jobs, all that would run fine, and that's the way things would run. So let's look at I can even look at all the applications which have been finished, and then look at individual logs. In my log not enabled. Now you see things have been written here, and looks at what the values are first, and then we look at that part. So HDFS, DFS, LS, we give a output 3. You got 32. Why got 32? If you look at, we have made 2 files input, and there are about 16 lines each with x:10. So if you look at that, you'll probably find, if I were to do grep, you get 16, and since we have 2 same files, so when you run a grep, the regmapper, it looks at all the input data into that file. So now we want to look at so this basically command tells me all the applications which have been finished, and you can see the job that have been finished, 33, 34, all those details, 58, and then you can look at the log status running, and these all things will run out. If you are doing clustering, log enabled, then you can actually log. Since this is not enabled, you will not see that this are not done on a local node, does not make sense. But you can look at individual logs, and individual logs are also defined. You can go to individual directory, which probably would be and you can look at different logs, individual node logs. And but if you enable clustering, you will see only in the YARN log, not individual log. So depending on how you want to debug, that's the way you can do it. Another topic mentioned in the book, though not mentioned in syllabus, is called pipes. Like what we normally do in streaming does pipe automatically, but if you want to do pipe internally through programs, they say you basically need using C++ standard template library to enable, then instance of mapper, instance of reducer, and extend those classes, define pipe. That's the way to do it. I'm not experimented with this, so I may not be able to explain you, but you can probably need more. And this is very brief information, so I'm not covering this pipe interface. It doesn't even mention the syllabus, but since chapter contains it, also let me just briefly mention. So we basically looked at today the chaining part of it. we did only sequential chaining, one MapReduce versus another. If you want to do multiple MapReduce in a tag, either you can use MRJob or you can do your own Java code, run things up, define dependencies, and that's what should be. So this brings to the end of our lecture today. And next lecture onwards, I would start with module 2. If anybody has any question, please let me know. We can discuss. Some of you